complaining about a teacher that didn't push record, and I was like, no, I can't be that person. Okay, so one sample, T interval, you've basically, I'm going to put the formula here, so two birds. You've got your estimate plus or minus the T number times the standard deviation. So you have the sample standard deviation over the square root of n. So that's for one sample. So the T number is basically like how, like from your estimate, how many standard deviations you're going to add up and how many you're going to subtract to like make your interval. So to find the T value, let's just do an example. Let's say we have a 95% interval. I mean, that's the popular one if you haven't caught on to that. But a 95% interval. So like, let's say, all right, here's my point estimate. I'm going to add and subtract a certain number of things. And I need to figure out, how much I'm adding and subtracting. So it's kind of like your 95% is positioned in the middle. And then to figure out this location versus this location, you have to know how much area is left over here. So this is 2.5%. Like the whole thing is 100%. So then on each tail, since it is symmetrical, you got 2.5% left on each tail. So then on the calculator, what you're going to do, and mine's old and doesn't have it anymore, but on your graphing calculator, if you have one, or if you use the one on your Chromebook, you're going to push the second button, that's the blue button, and then you're going to push the vars button, and then you're going to have an option that says inverse T. And then there's two things you plug in here. Depending on how upgraded your calculator is, you might have to like separate the two things by a comma, or it'll say like area and then DF for degrees of freedom. So for the area, you're plugging in the 2.5% as the decimal. So 0.025. And then the degrees of freedom relies on the sample size. So degrees of freedom is basically how much wiggle room we're allowing ourselves. And basically the T distribution adjusts itself for the sample size that you're using. So like if I sample more things, the T distribution starts to look more normal. So the bigger the sample size, the closer it gets to like the normal curve. And the smaller the sample size, basically the fatter and wider it is. But it allows us to like make better estimates for this type of situation with the change in if the sample size changes. So degrees of freedom is always calculated as n-1. So if I had a sample size, I don't know, of 20 things here, then my degrees of freedom I plug in on the calculator would be 19. And then I would just hit enter, and it's going to give you a negative number. It'll always give you this side. You just make it positive in your formula because you're adding and subtracting it. So just add and subtract, the positive number. But so that's for one sample, Saul or anyone else, because standard deviation formula is right here, actually, Lillian, for this one. So any questions on this one, feel free to also unmute yourself. It could be quicker. I don't know. I could also hear another voice, which is nice, but either way, virtual learning. Woo. Any questions on this part before I do the calculator business for the two sample, which is a little more intense? Okay. If you are typing a question, I can't usually see that. So if you are typing something, I'll just keep doing it and hit enter, and I'll stop talking and slow down. Okay, so for the two sample, this is the formula. So two sample, you're looking at two samples, but you're looking at the difference between them. So you'll be given like one sample and its average and another sample and its average, and you'll look at that difference between them. And then plus or minus the T, like it's kind of like a Z-score. So like that T number times the standard deviation, which looks kind of gross, So it's going to be the standard deviation of the first sample squared over the sample size of the first one. This formula is given, by the way. You don't have to memorize it, but that is what it looks like. So you've got both of your sample standard deviations, which are provided. These numbers are given. Your sample, the standard deviation from each sample, and then their respective sizes, and then it's just it's a plug and chug technically. But there's a calculator hack. So let's talk about that. So for this one, this was the lesson from Wednesday. The degrees of freedom on this one, when you have two samples, is a gross, nasty formula that I'm never going to teach you. I don't even know it. I've seen it once, and it was like too much. So we don't teach that in AP Stats at this level. There's a crazy formula to get it when you've got two samples. You don't need to know it. So here's our calculator hack, which is a little annoying that we have to use a hack, but it is what it is. So step one on your calculator is you would, yeah, okay, so I was to remind myself. Okay, step one, you're gonna hit the stat button. And then you're gonna go over like the two spots across the top menu and it says tests. And once you get to tests, you're gonna click on, and the order might be a little different because the calculators update every once in a while, and sometimes the order changes of these things. But for me, it's like option 10. It says to samp t-int, which is a two sample t interval. There's a z interval option. We're not using that one. That's a whole other story for a different day. So for you, okay, so this is gonna calculate like your interval. It's going to give you a bunch of stuff. So you can input both of your samples. You can input all the things and then hit enter, and it magically spits out the interval for you. The other thing it'll spit out once you hit enter, like input your data from the question, like it'll give you your interval, and then it does give you the degrees of freedom. And it's usually crazy decimal. So like it's some sort of wacky thing. It doesn't give you the T number. Don't ask me why. It doesn't spit that out. I don't know. But it does. So let's just say, I don't know, let's say the degrees of freedom for this hypothetical thing is like 42.6 or something. So then you go on your calculator a second time and you go, okay, I got to find the T number that goes with whatever area I'm using, which usually is going to be a 95% interval. But then you go back and basically do what we did over here. So you would go back and go, okay, inverse T, and I plug in my area, comma, or however your screen is set up, and then put in the degrees of freedom you got from over here. And then hit enter, and it'll spit out a T number for you that you could then stick back in your formula, which is a little bit ridiculous, but that is how that one works technically. So that was a lot. Button pushing. What questions do we have? Feel free to, you can unmute yourself too if you want, shout at me. Or drop it in the chat. So all those are all the calculator button pushing things. Unfortunately, my calculator isn't working, my virtual one. Figure that out. Does that clear up calculator questions? And then Lillian, standard deviation is given in both of these. So what questions do we have? Okay. So Saul, do you feel ready for the quiz today, or do you still want to go, like, I'm going to go through an example here probably next. Kai wanted an example. You're good? All right. All right. So there's, yeah, I'm going to drop the link there. And then I'm going to shoot you to that other breakout. But grab that link first. Oh, no, not that button. Oh, God. Yeah. Join this other silent breakout room. All right, I'm gonna hit save. Lillian, so I'll just grab that link. And then you should be able to pop out. Say some pairs. I think I did it right. Yeah, okay. Okay, so Kai and
Hi.
Yes.
Can we talk about the calculator stuff for the 2 sample real quick?
We sure can. Let me just, Tessa, grab that link. I'm going to bump you out. Yes, Lillian, yes, I can. Yes, I can. That's a terrible thing about Google. You leave a meet and then clears out the chat thing. Okay, who am I moving? Tessa. I'm moving Tessa. Save. Oh, hello, Erica. Hello. Erica, we're doing, I don't know how much you've caught on to. Sorry, I didn't have this attendance thing open. Erica, we're doing a recap, or people are starting the quiz today. So I know you did all the assignments, but we do have the option of either recapping and then doing it, or you can even do it on Monday during advisory as the third option. So if you want to drop in the chat what you're feeling, you're ready to take the quiz now, or if you want to do a recap, let me know. Okay, Kai, what are your thoughts? Feel free to unmute. It's more fun that way.
Yeah. So when I click on the 2 sample t interval on the calculator, it brings up a bunch of like stuff to like fill in, like list 1, list 2, frequency 1, frequency 2. Is that the right thing I'm supposed to be looking at?
Yeah, no. Well, yes and no. Hold on, let me bring mine up so I can direct you. Go to. So yours is. So that, okay, we will use that one later if we actually had raw data. But for the questions that we have, if you look at the top of it, there should be an option that says data or stats.
Sure, yeah.
Okay, highlight the stats, like use your arrow keys, and then hit enter on stats, and then you're able to type in the average from the first sample, the standard deviation that's provided, the sample size. You can just enter those in. Yeah. And then don't pool it. That's the other thing. Don't hit the pool button.
All right.
That's not good.
That makes a lot more sense. I was very confused. I was like, wait, none of this.
Oh God, yeah, I was in the video on
understand.
Wednesday, but I didn't just now say it because I forgot myself. So yeah, thank you for asking. Yeah, so those numbers will be given for now. We will do some with raw data next week. I'll show you how to like do it with the other way. It's just a lot of calculator business. So how do you still want to go through an example then?
Yes, I do.
Totally fine. Let me just, so Erica, Lillian, do you have the link now? I hope. And Erica, I dropped the link in the chat. Yes, okay, great. And then if you guys, Erica, I'm gonna move you to a breakout room so you don't have to hear me talking. So I'm gonna hit save and that should open for you. Just grab the quiz link. Okay. Lillian, do you still have the option to? I don't know. Okay. Yes, okay, great. Okay, and then Chris, I know you were working on, it's at the top. Okay, great, good. Glad we got that figured out. Okay, this is all being recorded. How fun. Okay, Chris, I know we talked, you're gonna do the quiz next week, Monday or Tuesday, I guess you can. I know we mentioned checking in Tuesday. Chris, do you want to work on some of the assignments that we talked about yesterday? Or do you want to hang out with Kai and go through another example? Feel free to drop it in the chat or unmute if you're there.
Yeah, could I stay for a little bit?
Yeah, hang out as long as you want. More the merrier. Okay, this will be much more fun if we just actually speak out loud to each other, so that's great. Do you guys want to do 1 sample or 2 sample example?
Would it make sense if we did a 2 sample, then it would like be easier to do a 1 sample after that? Is that like this one?
Yeah, it's pretty much the same thing, but the calculator business is just gnarlier for the 2. Well, I mean, it's just we can do that. That should work. Okay, so let me bop to the right page. Okay, so here's a question. I can just kind of read it and then we'll highlight some information we think is important. So I'm praying I grabbed a 2 sample. I'm pretty sure I did yesterday. Okay. Ooh, not that. Don't click that button. Okay. All right. The Pew Research Center poll asked independent random samples of working women and men how much they value job security. Of the 806 women, 709 said job security was very or extremely important, compared with 802 of the 944 men surveyed. Construct and interpret a 95% interval for the difference in the proportion. Oh no, I grabbed a proportion one. Shoot. Hold on. Copied it from the wrong page. Oh no. Just a second. It's like, wait a second. This has got a lot of numbers in it. Why does that look weird? Ooh. Pause. Happy Friday. I grabbed one from the wrong page. Oh, all right. Yeah, I'm doing things in a slightly different order than I did last year too. So sometimes I'm basically ripping apart all my chapters and putting them together in a different order because I think it makes more sense. And well, probably grabbed, all right, what chapter would this have been last year? 10.3, I think. Let's see. Oh yeah. Here's like, oh no, not that one. 10.2. Let's try this. Gosh, sorry. I want this one. Yeah. Okay. Let's. 2 things. Yes, this is one. Copy paste. So we're eventually I'm going to show you this calculator trick, but you won't need it on the quiz. The quiz, I'm going to give you all the numbers.
Okay.
But we will eventually use raw data and go through like how to, if I give you just a pile of data, what do you do with it? And stuff. So, okay. So let us take a peek at this one. Sorry. Okay, Mr. Wilcox's class performed an experiment to investigate whether drinking a caffeinated beverage would increase your pulse rate. So 20 students in the class volunteered to take part of the experiment. Of all the students measured their initial pulse rate in beats per minute, then Mr. Wilcox randomly assigned the students into 2 groups of 10. Each student in the first group drank 12 ounces of cola with caffeine, and each student in the second group drank 12 ounces without. All students were measured their pulse rates, and then again, the table displays everybody's pulse rate, and also gives us the mean change over here. So this is like our average, and then I went ahead and calculated these numbers, but I'll show you how to do that on the calculator next week. You don't need that for the quiz. Okay, so aside from the 2 things I circled, is there anything else in the problem that looks like we want to note that?
Well, we got the Mr. Wilcox randomly assigned the students, so we know that it's going to be a random sample.
Yeah, we did. I mean, he's using his class, but we did for an experiment. Yeah, we do want random assignment because that at least ensures that people didn't pick which group. So sometimes for a 2 sample thing, you can use an experiment instead of sometimes randomly selecting people, as long as you randomly assign. So that's going to fit our random condition this time. Anything else that we should take a peek at?
Is it important that we know that there are 10 people in each group?
Yeah, because we're going to need to match up when we do the interval. We'll need to know the sample size for each of our groups to do our calculations. So for group 1, I mean, they are both each 10 people. So I'm just going to put that over here on the side. So for group 1, we have 10, and for group 2, we also have 10. So let's go ahead then and go through kind of the steps. We're going to construct a confidence interval for the true difference in the change of the pulse rate when we consume essentially caffeine. So for your first step or your state portion, you do want to describe to somebody and show like, here's what we're measuring. So for this one thing to remember is X bar is always the average from your sample. So these are like our little X bars right here, X bar 1 and X bar 2.
Okay.
Mu is going to indicate the population number. So like this is the true value. If I had everybody in, every high schooler do this and see what their pulse rate was, then that would be kind of my true value. So those are the two symbols used this time. Instead of like P and P hat, now it's going to be X bar and mu, the Greek letter mu. So for this one, we're hoping group 1 minus group 2, the average pulse rates between the two groups. We're basically, what I like to do is I just like to steal the words from the question. So this is the true difference, true mean difference, copy the question, let's copy the question, true mean difference in change of pulse rates for subjects. And you can include like these, because if he only uses people from his class, I can really only generalize my findings to a group that would be similar.
Right.
Because I couldn't generalize it to like every high schooler ever, because I didn't sample from, randomly from everywhere. So, so who drank caffeine and who don't. So that's basically just copying the words. So the state part is like, okay, what is the difference that we're trying to examine and we're trying to create an interval for? What are we trying to estimate? And then we just have to report our confidence level. So in this case, our confidence level is going to be 95%. So that's kind of your state part, telling people what you're estimating, and then, or creating an interval for to estimate it. And then how confident are you trying to be in that estimate?
Okay.
Then for the plan part, that's where you got to name it. And then, it's like every kid has to have a name. So we got to name the thing. And then we're going to check our conditions. So for this one, our name is going to be a 2-sample T interval for, because again, we're going to construct a range of possible numbers for, the population difference there. And then we always have our 3 conditions. Never change. So always the same. So condition number 1, you already mentioned it, Kai. It's the randomly assigned people. So we got that one. So we've randomly assigned students to groups, or we can say students to treatment groups, since we are doing an experiment here. And then this is so we can generalize to a similar group our findings. Okay, and then for the other 2 conditions, we have to do the 10%, and we have to do large counts. With the large counts condition, we do have 3 options this time, so that's where it gets a little dicey. Option 1 is that in the problem, they just tell you like these distributions for both samples, like the population for each one of these, like the population of caffeine drinkers and the population of not caffeine drinkers would be like approximately normal. So if they're giving you the population is normal, then you can say, yeah, cool, all right, our sampling distribution is going to probably be normal then too. Like it'll reflect the same shape. The other option is that the populations they're coming from are not normal, but your sample size is large enough, meaning specifically greater than 30 for each group. That's the central limit theorem we did like way long time ago. Right. And that's not true here either, because we have a sample size of 10 for each one. So then the third option is just to check that the data they gave you for each group, you just make a quick little dot plot, and you check that those look roughly symmetrical, or they don't, basically you're checking that they're not skewed, essentially is your shtick. So for us, we would almost like I've done this before. So let me grab the dot plots. So for us, we would just want to include on here 2 little dot plots of each of our results that we're given above. Just do a little quick sketch. And then we would say here the sampling distribution. So if I were to do this over and over and over again, is approximately normal. Since each sample, you can say looks approximately normal, or there's no strong skew in either of these dot plots. It looks roughly symmetric. Just throw that little word roughly on there, and then we feel better about things.
Okay.
So since each of the little samples is producing sort of a symmetrical pattern, we can assume when we subtract, match up and subtract and get all the differences for each one, each pairing, then we would be like assuming that all those little differences eventually will also make a symmetrical pattern. We just feel better about life when things are a bell-shaped curve. So then for the 10%, we're just assuming 10 students is going to be less than 1/10 of all students in his class. But this one doesn't work well here. So when we report our results, we just say we report them cautiously because our 10% condition is a little violated here with, the number of kids in a class. But
yeah.
But then as far as the formula goes, any questions on the state or the plan so far?
No, I was a little confused on the large counts one, but now that like you showed that there's that option of creating the dot plot, it makes sense.
Yeah, and that'll be the same for a 1 sample. So 1 sample, it's like, is the population I'm pulling from normal? Is that given? No. Cool. How big is my sample? Not big enough. Okay, let me make a dot plot and just make sure the data doesn't look crazy.
Okay.
So for a 1 sample, you would just have like 1 dot plot.
Yeah.
So that's none of this changes, well, other than the name, you put a 1 there, but for the other one. So, okay. So then for formula, so the do step, you want to go through a little bit of the calculating?
I do, yeah.
Okay. So let's take a peek. So I'm going to do basically my point estimate, which is going to be the difference in pulse rates for my 2 groups. So I'll pull my data back up and take a peek at what those numbers were. Plus or minus, I have to decide like, okay, how many standard deviations to add and how many to subtract. And so we use a T distribution now. So it's like how many standard deviations. I got to do all that calculator crap to get this number, which is annoying. And then our sample standard deviations. And this formula is given, like this part of the formula is given. You kind of have to remember the rest of the setup. So it's like, what thing did I get from my sample that I'm curious about? All the average pulse rates for each one. And then I've got to remember I'm using T now instead of a Z-score.
Okay.
So for right now, we're just going to plug in everything we have. Let me go back and double check my numbers. So we had 3.2 and 2 were the average for each group, was the average for each group. So that's going to be, what, a difference of 1.2 when I plug that in.
Yeah.
So group 1, so 3.2 minus 2, which is going to be 1.2. And then T we'll find in a hot second. And then my 2 standard deviations are just plug and chug. So 2.7 and 2.62. So 2.7 over 10 and 2.62 squared over 10. Which all of that is gross to plug into the calculator, which we're just going to make the calculator do it for us. So that's the beauty of that. And that is a very valid AP test trick. When in doubt, hit the stat button. Okay, so for this one, if I go to, I don't know if you want to follow along with your Chromebook calculator or not. This is my calculator from like 9th grade. So this is a
Oh,
very old edition of the TI-84. But good calculators. They don't break. I dropped it
Yeah.
100 times. Okay, so two sample T int. So I'm going to go to stats because they've given me all the stats for each group. They've given me the average and stuff. So for group 1, the average pulse rate was 3.2.
Right.
Little SX1 is the standard deviation for that group. So you just plug that in. You don't have to square it. It's going to do all that.
Okay.
And then N1 is 10. That's your sample size. And then X bar 2 is 2. And then standard deviation for group 2 is 2.2. And then sample size of 10. And then it asks for the confidence level. We're going to do 95%. So that's always defaulted. Usually it says 0.95. You just leave that. Do not pool it. That's a conversation for a different day. Just always have no on that and then hit calculate. Or for yours, it might say paste. And just keep hitting enter until it gives you something.
Okay.
Sure. Mine, I just have to calculate. I think it says paste now or something.
Oh. Okay.
Okay, and then let's see if our numbers match. I don't know if you were following the whole time, but.
Well, I had it, then I clicked enter, then it gave me a thing, but then I clicked enter again and it's gone now. But it saved, so let me just go back to it.
Okay. Yeah, let me see. I got negative 1.3 comma. So my interval, plausible values, I'm around. I got plausible differences in the pulse rates to be between a negative 1.3 and 3.7 on
I
average.
agree with that, yeah. And you rounded up like the 3.7 up to that,
Yeah.
right?
Yeah, you can round anything in stats as long as you round correctly. So
Okay.
that's totally fine. The only other thing we want to copy here is our degrees of freedom. And I probably wouldn't round this. I would round it, like, I wouldn't round it up to 18. I would round it to like, so my calculator gives me like 17.98. I would do that. So that's my degrees of freedom. So then I can use that to go back and find this T number so I can plug in my formula correctly. So in your calculator is going to be fancier than mine probably. So I'm going to hit the bars button. Oh, no. Oh, you're going to have to do it because my calculator doesn't have inverse T. Fun fact.
Oh, really?
Yeah, it's old. So the first couple of years teaching stats, I was like, all right, guys, we're going to have to use the table. And then someone finally went like the paper table and someone was like, wait, but my calculator has inverse T. Like the school ones are upgraded like just enough to have that. And I was like, seriously? I don't have it.
Nice. So is it the second verse? Is that what we're pressing?
Second bars. And then I think it's option 4 maybe on yours. I don't know. Somewhere it says inverse T. Okay, hit that. And then for yours, it probably says like area and then degrees of freedom, DF or something.
Yeah.
Okay, so we'll put in 0.025 for the area because we've got a 95% interval. So that means 2.5% is the number we want for those tails. And then
17.98 for the degrees of freedom.
Yep.
Okay. And negative 2.1.
Yeah, so we'll just make that positive to represent it in our formula.
Right.
2.1, is that what you said?
Yeah.
All right. So we'll put 2.1 there. So basically we have our average difference between the two groups for their pulse rates is 1.2. And we're going to add about 2 standard deviations up from that and 2 standard deviations back to make that range of numbers is basically what that's saying.
Okay.
So that's what we got here is our interval. So then to interpret it, we just say we're 95% confident that the interval from, put in the numbers, negative 1.3 to 3.7 will capture this true thing we were trying to estimate. Will capture the true mean difference in the change of the pulse rates for so that's where you just basically plug this is what you're trying to estimate. So now we have an estimate for this true difference if you're drinking caffeine versus not. So we think it's somewhere between negative 1.3 and 3.7 on average is what we think that difference is between caffeine drinkers and non-caffeine drinkers. So one popular follow-up question here is always to look at the interval and then ask a question. So they usually ask something like, do you think there is like a significant difference between the two groups, or are you convinced there actually is a difference between the two groups? And on this one, we would say no, because 0 is in the interval, because the interval goes from a negative number to a positive number. So I can't be 100% certain. I mean, we can never be 100% certain about anything, but I can't like really say that I'm convinced that for sure there's a difference between the two groups, because 0 is a plausible value. That's always a popular little follow-up question as to, are you convinced about, is there really a difference in caffeine drinkers and this and that? And so that's just one thing to think about. That is not asked when you're doing a one sample test or interval test or the next chapter. Yeah, so that's it, because you're not looking to compare two groups, but here we are. So it's like, you're going to get a negative difference potentially because you're subtracting numbers. So yeah, does that logic kind of make sense with 0 being in the interval?
It does, yeah.
Okay. And that's pretty much it. These are log problems. But that's a 2 sample. A 1 sample is just slightly quicker.
Right.
You can do the 1 sample interval on your calculator if you do stat and test. It will also do the 1 sample. I don't know what option it is. Hold on. It's either gonna, let's see. I think it's just T interval.
That's what I was thinking, yeah.
Okay, yeah, I guess mine's an old one, so I don't know if they actually put 1 samp T int in there or if it's just T interval. Yeah. So you can calculate the 1 sample using the same thing, but with the 1 sample, you don't have to do the crazy crap with the degrees of freedom, because the 1 sample, you're just going to do n-1 because you only have 1 group. So that one we always calculate by hand and then just do inverse T and get our numbers. But the 2 sample, we do not. So there's a giant formula to get degrees of freedom. It's very gross. You don't want
this cleared up a lot of things about this.
Okay.
I was very overwhelmed during the practice. But now it's like, oh, it's just a bunch of numbers I have to plug in, and it gives me a thing in, so it's a lot easier.
Yeah. Okay. Well, I'm glad that you feel better about that. Chris, I don't know if you want to drop in the chat or you can unmute. I don't know how you're feeling about things. If that was helpful or not, but